Chapter 9 is a lot of graphing. Chapter 9, the second section, is equations of parabolas. So we're going to revisit parabolas and we're going to look at a different way to look at that equation that I think is going to make it easier to graph. If you'll remember, what we had before was y equals a times x squared, and this was only a parabola that opened up or down because if you turned it to the side, it wasn't a function, and we've only been dealing with functions up until now. Here we go. So what we had before is that y equals ax squared opened up or down with a vertex of 0, 0, and the axis of symmetry was at x equals 0, and it was always a vertical line. Now, what we're going to do is we're going to look at two more terms, focus and directrix. Hang with me. This is a little bit difficult to understand, but once you get it, it makes sense. So the focus is a focal point. It is a point within the curvature of the parabola. The focus and the directrix are directly related. The directrix is a line that's perpendicular to your axis of symmetry. And this line, the reason we have these is the directrix and the focus are exactly the same distance from the parabola from every point on that directrix. So, in other words, so the focus obviously stays in the same place. So from the focus to the directrix here, obviously is the same distance, because what we're going to do is the focus is the point 0, p, and we're going to use p as the distance either up or down or left or right that the focus is. The directrix is always going to be the negative of whatever p is. So the directrix is y equals p, or negative p, sorry. In this case, y equals negative p. It's going to be the opposite of the distance. It's going to be the same distance, but the opposite direction from the focus. All right, hang with me. It's okay. We're going to get there. So we start out with that point. Now, anywhere on this line, the distance to the parabola, the curvature of the parabola, is going to be the same. And obviously, my graph isn't to scale. If you look on page 620, their picture is better shown, because these distances should be equal, and obviously on mine they're not. So if you go over here and go at a right angle up to here, these distances should be the same. So yeah, definitely look at the picture in your book because that makes a little more sense, because the parabola is drawn more to scale, so the point is though, the focus and the directrix are related, and the reason we need those is because it gives a frame of reference for every point on the parabola. Now that I've said that and confused you, let me give you the actual formula. And once again, with these formulas, what I've done is I've broken it down into the way that makes sense to me. If it doesn't make sense to you this way, look in your book, again on page 620, and they have a graph of each one of these. And so if you're more visual and need to see each one of those graphs, look in your book on page 620. What I've done is I've made it succinct into what makes sense to me, because we're going to take this formula for a parabola, and what we're going to do is, because those only opened up or down, if it opens up or down, then the x quantity is going to be squared. And if we solve for the x squared and get x squared by itself, then our formula is going to be 4 times p times y. So instead of that a, what we've done is divided that a by 4. And then what we get is this number, if you'll remember the p from your focus. All right. So P is the distance that your focus is from the origin. All right. So, and all of these are when your vertex is at the origin. We're going to stay at the origin for now. So here's your formula. X squared equals 4 times the distance to the focus times y. If this 4p, if your P is positive, then your parabola is going to open up. If your P is negative, then your parabola is going to open down. All right? Now, The same thing happens if you've got a y squared, but only a y term. If you've got a y squared, that means that you've got two y values for each x, which means that your parabola is going to open either to the right or to the left. And once again, if it's positive, then your parabola is going to open to the right. If your p is negative, then your parabola is going to open to the left. So, and once again, if you want to go back and look at the graphs, page 620 is where you want to go. So these are your two options. When you're graphing parabolas, here's a new way to graph them. When you're graphing parabolas, if you will get the either x squared or y squared value alone, then what you can do is divide your constant by 4, and that gives you your focus, the value of your focus. Let's do some so that you can see what I'm doing. All right, so here's what we're going to do on these. I'm going to say graph y squared equals 20x. And you can look at this equation. You can look and see, well, y squared says that it's going to open either to the right or to the left. Because this value in front of the x is positive, we know it's going to open right. So we can just put here, opens right. Okay, did you see why? Okay, because the y squared limits it down to left or right. Positive means it opens right. So I know it's going to open to the right. And I know that my focus is going to be 20 divided by 4, which is 5. So my focus is going to be 5. 1, 2, 3, 4, 5. So the larger that focus gets, the longer the distance is between, so the wider your parabola gets. So that's how you can know. So once you've gotten that, and you know that your axis of symmetry, because it opens to the right, you know your axis of symmetry is going to be a horizontal line, and so that horizontal line is going to be y equals 0. And all of these are going to be either x equals 0 or y equals 0 because we're starting at the origin. All right, so then in order to get, okay, exactly how wide or how narrow is this going to be, let's put in a few x's and y's and just put, if your y is squared, you're going to put in x's and get 2 answers out for your y. So let's put in positive 1, 2, and 3. Because we've got positives here. And what I did was I just put them in. I just put them into the calculator already. So 1 times 20 is 20, and the square root of that is 4.5. So I've got plus or minus 4.5. And then 2 times 20 is 40. The square root of 40 is plus or minus 6.3. And then 3 times 20 is 60. The square root of 60 is 7.7, so plus or minus 7.7. So then, when we plot these, I'm going to go 1 over and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I should have done that before. Okay, so 1 over and then 1, 2, 3, 4 and a half here and down. Don't forget negative. 1, 2, 3, 4 and a half here. Oh, see, mine isn't very symmetrical. 6, 3. So 1 over, if you use actual graph paper, this is going to look a lot nicer. So 1, 2, 3, 4, 5, 6 and a half is about right there. And let's make it about the same. 1, 2, 3, 4, 5, 6 and a half is about right there. And then 7.7 is that 6 and a half. Here's 7 and a half is up here and down there. And so then your parabola is going to look like that. And probably a little wider. I don't think I counted all the way down to 7. All right? So if you have an x squared means that it's going to open up or down. And before you can start graphing, you've got to, remember, you've got to solve it. You've got to get the x squared by itself. So you're going to divide by the 5. So x squared actually equals negative 3y in this case. So now we can look and see, well, let's see. Negative with an x squared, it's going to open up or down. And if it's negative, it's going to open down. It's going to open down, and we know that the focus, and actually, you know what? Not just 5, but it's 5, 0 in this case. All right, it's a point. The focus is a point. And the focus here is going to be, now be careful, because the focus is going to be, it's going to be this number divided by 4. So it's going to be -3/4. And now, because it opens down, it's going to be 0 over and -3/4 down. So it's going to be just right here is your focus. So this is going to be a very narrow, because our focus is so small, and so our directrix would be at -3/4. That's not even a straight line. Our wobbly directrix. So that means that that distance between the parabola is going to be, it's going to have to be kind of narrow here. So we've got an axis of symmetry again of x equals 0 this time, because it's a horizontal line. Okay, so now in this case, what I would do, instead of putting in x's and having to take all those square roots, I would put in the y's. Now be careful, because this is a negative focus and a negative, then your y's are going to have to be negative because it opens down. All of your y's are going to be negative values in order to make this positive, the right-hand side of your equation, a positive value, so you can take the square root. So -1, -2, -3 is what I would do. And then I would put it into this equation, not your original one. So -1 times -3 is a +3, and the square root would be plus or minus 1.7. -2 times -3 is +6. Square root of +6 is plus or minus 2.4. And then -3 times a -3 is a +9. Square root of 9 is plus or minus 3. So then when you plot those points, you're going to go, let's see. So now when you've got the -1y, you're going to go positive 1.7. 1.7, here, 1, 2, 3, 4, 1, 2, 3, 4. Those are bigger. Let's make this one bigger. I should have put my lines before I started the video, huh? There you go. And then I could have gotten a little more. Okay, now that's a little more exact than the one up there. Okay, so 1.7 is almost at 2, -1, and -1.7 and -1. There, these are a little bit more exact. And then you've got 2.5 almost, and -2 is about here, and 1, 2.5, and -2. And then 1, 2, 3, and down 1, 2, 3, and -1, 2, 3, and down 3 is there. And now, you can see that except that my lines are closer together, so it's not quite as obvious, that because my focus was at 5, your parabola is wider, and this focus is -3/4. So 3/4 is much smaller than 5, obviously, so it's a narrower parabola. All right. So, are we all totally confused now? So opening up or down has an x squared. Opening right or left has a y squared. Now, this is going to be, when we're writing the equations, this is where the p-value for your focus is going to come in super duper handy. All right, because this is going to make these problems way easy. I want to write an equation for a parabola, and this is 2 different problems. The first one is, it's got a focus of -3, 0, and a vertex of 0, 0. So in your brain, you look to see, okay, the focus is -3, 0. So the focus is over here. So that means that it's going to open to the left. So go to your handy dandy little chart. If it opens to the left, it's going to be in this format. So y squared equals 4 times p times y, and it's going to be negative, right? So your p is going to be negative. All right. So what we're going to do is this. We're going to put in the p, remember, is this -3. So y squared equals 4, put in your -3, y. So y squared equals negative 12y. And guess what? That's it. You're done. Ha! How easy is that? Okay, same thing over here, except that you've got to be careful. This is a 0, 10 focus. So the focus is 0 over and up 10. So if it's up 10, if the focus is up 10, then you're actually going to open up. So if you're opening up or down, you're going to use the x squared formula. So x squared equals 4py. Oh, guess what? This should have been x all along. Oh dear, totally messed you up. You were like, what? Why? We have two y's? Y squared equals 4px. You should have an x and a y squared or a y and an x squared. Fix it quick. Can your brain fix that in your brain? Okay, so now the p is the distance that the focus is away from the vertex. So you just put that in. X squared equals 4 times 10 y. So x squared equals 40y. You're done. That's it. Ha! Those are going to be super, super, super simple. All right, so once you've got this in mind, okay, x squared is up or down, positive is up, negative is down, y squared is right or left, then graphing them shouldn't be any problem. You are going to pick one or two or about 3 points just to get how wide or how narrow is this parabola going to be, and then just graph them. Or the other part of your homework is finding an equation. You can do this simple, easy, and I'll see you later.